In this video, we're going to take a look at polygons and areas. We're going to concentrate on triangles and quadrilaterals. And quadrilaterals are nothing more than a four-sided polygon. So things like rectangles and squares. Now, there are other polygons like, or other quadrilaterals like kites and rhombus, and that we are not really going to consider at this point. It's not particularly pertinent at this time. However, we can always derive those later. And so, in general, the area is the measure of a surface of a figure. And right now, we're just talking about planar geometry. We're not talking about solid geometry or any of the non-Euclidean geometries. But just in planar geometry, the area is the measure of a surface of a figure. And so some common areas would be those of rectangles. And if you have a rectangle here, then you have a length and you have a width, and if you multiply that length and width, you will get the area. Okay, the square is just a specialized rectangle. It just happens to have all four sides equal. And so if you have one side, then you have all the sides. And so if you apply the rectangular formula, then you have s times s, which is s squared. And so those are the two most common, I would say. The next most common would be the triangle, but we're going to kind of take a look at a doofy rectangle here called a parallelogram. Now, the rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle. Most people identify the parallelogram as a rectangle that's been kind of tipped over on the top. And so we don't have any right angles necessarily, but we do have a height. This is its height, or this is its height. The height does not have to be measured inside the figure. It can be measured outside as long as it is perpendicular to the base that you are considering. And so the base is going to be this part right here, and that's that horizontal line. Now, the other base is equal to this in the parallelogram, but that you can prove. And so it's not an assumption, it's a theorem. But that's the area of a parallelogram. A triangle can be shown as any triangle is half the area of a parallelogram. And so if we take any triangle, then we take its height. Again, it doesn't have to be, that's going to be a little on the small side. Let me go ahead and erase that here. Well, why is it grabbing? Oh, because I'm pushing the button. Okay. Let me grab a bigger triangle here. And so the height is going to be perpendicular to the base, and its area is 1/2 the base times the height. Now, there are other triangles that aren't necessarily that nice, and they are called obtuse triangles, where they have one angle that is greater than 90 degrees. And you might say, okay, well, where's the height on this one? Well, again, you don't have to be on the inside to grab the height. But you do have to be careful, because the point or the vertex where you grab the height from has to drop down to the opposite side. And so if we extend this side out, this has to be perpendicular to that side. This is now the base, and the height is outside of the triangle. You could also accomplish it by the same way, just by dropping a height this way, and then this would be the base. That you could do also. Okay, this last one, we're going to go ahead and I'm going to show you. It is not, the parallelogram, by the way, is assumed. Everything is based off the area of the parallelogram. The triangle is proven to be half the parallelogram. So the rectangle is actually a specialized parallelogram, and the square is a specialized rectangle. So those two follow from the definitions. The trapezoid, however, is defined as a quadrilateral having exactly one pair of parallel sides. And so if I just draw kind of a really exaggerated trapezoid here. I'm going to mark the top and the bottom with arrows. This signifies that they are parallel. And so now what I can do is I can split this up, and this is a very, very nice way to do area problems, where if you have oddball shapes, you can actually split them up. So I'm going to drop down and make two triangles and a rectangle. Okay, this rectangle is going to have a height of h. Now the top thing I'm going to call base 1. And I'm going to nickname that B1. And the bottom, the whole mess, the whole length, I'm going to call base 2. And I'm going to nickname that one B2. Now the biggest problem is I don't know what this is, this right here. So that triangle base right there, I don't really know. So I'm going to call that A. And then I also don't know the other triangular base, and I'm going to call that B. I don't want to call that B because I'm going to get it mixed up with my other bases. Let's call it C. Alright, so now let's go ahead and find the area. Well, if I want to find the area of a weird shape, and I could split it into little shapes, then I'd just add up all of the areas of the little shapes. So I'm going to mark this as area 1, this is area 2, and this is area 3. And so area 1, that's a triangle, and so it's 1/2 the base, which is A, times the height, which is h. In area number 2, it is a rectangle, and therefore it has the base, which is B1, times the height. That is its area. And finally we have number 3. Number 3 is another triangle, and so it's 1/2 the base, which is C, times the height. Now all I have to do is add all of these things together, and I get my new area. And so if I take 1 and I add it to 2 and I add it to 3, then I get 1/2 A times H plus B1 times H plus C, or 1/2 C times H. Okay, the next step I'm going to perform here is called factoring, or it is simply the distributive property worked in backwards of what you normally see it. If you have never heard of the distributive property, this is not going to make a lot of sense to you necessarily, at least not at first. And so what I would have you do then is just accept this next step as gospel. And so this next step is going to factor. I'm going to factor out a 1/2, and I'm going to factor out an H. And when I do that, I get A, H, not H, that's gone, I apologize. I'm going to get A plus 2B1, because I factored out a half. I had effectively divided 1 by 1/2, and that gives me 2, plus C. Now at this point, most everybody, if you're studying this particular thing or segment of geometry known as area, you should have had basic addition, subtraction, multiplication, and division. What I'm going to use now is the definition of multiplication. Multiplication is just shorthand for addition. And so what I'm going to do then is I'm going to say, if I have 2 times something, we'll call this 4, I'm actually going to add 4 to itself, and there will be 2 instances of the 4. So if I have 2 times something, 2 times B1, it's really A plus B1 plus B1 plus C. Okay, now this takes a little bit of making the jump from green to purple here. Takes a little bit of faith and a little bit of creative thinking. The next part does also. It's a recognition thing. I have A, B1, and C. And I need to know, is there anything else that I can make into that? And well, if you look at base 2, the bottom, it's A, and then there's a B1 here. And so really that entire length of base 2 is A plus B1 plus C. A plus B1 plus C. And so I can gather those up, and that's my B2. So that's what gives me 1/2 times the height times base 1 plus base 2. And you'll notice that formula right there matches this formula right here. This is just to let you know it's not magic. It doesn't come from just out in space somewhere and it's magically brought to us and said, oh, this is right here. Okay, there's something to it. And so try to be a little bit on the skeptical side of things, I guess is what I'm trying to say.